Have you ever contemplated the mystery and awe of black holes? These celestial phenomena are more than just the stuff of science fiction. They are incredibly massive, super-dense objects in space, the result of the gravitational collapse of a supermassive star. Imagine a star many times larger than our Sun, reaching the end of its life. It explodes in a supernova, and then the remaining core collapses under its own gravity, creating a black hole. This gravitational force is so strong that nothing, not even light, can escape from it. This is why we call them black holes. They are invisible to the naked eye, only detectable by the way they affect the space and matter around them. Now, you might be wondering, just how powerful is a black hole? Well, they can devour stars, and yes, even other black holes. They warp the fabric of space-time, creating a gravitational pull that is irresistible. And yet, despite their power, they are also silent, hidden players in the cosmic ballet of the universe. The nearest black hole to Earth, known as V616 Monocerotis, is about 1,000 light-years away. That's roughly 6,000 trillion miles. But don't worry, at such a distance, it doesn't pose any threat to us. The black hole's gravitational influence is not strong enough to affect our solar system from its current position. So, while black holes are incredibly powerful, we are safe from their reach here on Earth. They remain one of the universe's most fascinating subjects, a symbol of the immense and captivating power of the cosmos. They are a reminder of how much there is still to discover, a testament to the endless intricacies of our universe. Black holes, in their silent, invisible majesty, continue to intrigue us, drawing us into the mystery and awe of the cosmos. Did you know that space is not as clean and empty as you might think? Circling our planet right now are over 500,000 pieces of debris. This space junk, a mixture of natural and man-made objects, presents a significant issue. The remnants of old satellites, spent rocket stages, and fragments from disintegration and collisions whirl around the Earth at speeds reaching up to 17,500 miles per hour. This is fast enough for even a tiny piece of debris to cause significant damage to satellites and spacecraft. NASA and other international space agencies are on the case, tracking this space debris to avoid catastrophic collisions. They keep a close eye on the larger pieces, which number in the tens of thousands, to prevent them from wreaking havoc on our space missions. So, space isn't just stars and planets, but a field of debris traveling at incredible speeds. Ever wondered how many stars there are in our galaxy? Let's take a cosmic journey through our home galaxy, the Milky Way. It's a spiral galaxy, a swirling mass of stars, dust, and gas that stretches across an estimated 100,000 light-years. Our Milky Way is just one of the billions of galaxies in the observable universe, but it's our home. It's where our tiny planet Earth resides. Now let's talk about numbers. The Milky Way is a bustling hub of stellar activity, boasting an estimated 100 to 200 billion stars. Yes, you heard it right, up to 200 billion. Each one of these stars, a glowing sphere of hot gas contributing to the radiant band of light we see across the night sky. But let's not stop there. The entire universe, as we currently understand it, is estimated to contain at least 1 billion trillion stars. That's a 1 followed by 21 zeros. Mind-boggling, isn't it? Each of these stars, just like our Sun, could be the center of its own planetary system. These staggering numbers give us a sense of the sheer scale of the universe. They remind us that our Earth, our solar system, and even our galaxy are but tiny specks in the grand cosmic tapestry. And yet, each star, each galaxy, contributes to the universe's intricate structure and its continued evolution. As we gaze at the night sky, we are looking at a tiny fraction of these stars. Every single point of light is a reminder of the unfathomable vastness of our universe and the myriad mysteries it holds. Each star, a beacon in the cosmic ocean, inviting us to explore, learn, and marvel at the universe's grandeur. With billions of stars in our galaxy alone, the universe is truly a vast and star-filled expanse. Our closest celestial neighbor, the Moon, is more interesting than you might think. Born from a dramatic event, it took a staggering 100 million years for the Moon to form after a Mars-sized body collided with Earth. This cataclysmic impact sent a cloud of debris into space, which eventually coalesced to form our Moon. Speaking of gravity, the Moon's is just 17% of Earth's. That's why astronauts can leap so high and move with such agility. Imagine weighing a sixth of your weight on Earth. And then there's the moon's shape. Contrary to popular belief, it's not a perfect sphere. It's slightly egg-shaped, elongated in the direction of Earth. That's right, the gravitational pull from our planet distorts the moon's shape. The moon, our constant companion, is not as simple as it seems. It's a testament to the dynamic and often violent processes that shape our universe. Ever dreamed of traveling to another star? It's a fascinating concept, isn't it? Well, let's take a moment to grasp the sheer enormity of such a journey. Now, suppose you decide to visit Proxima Centauri, our closest neighbor in the stellar community. Even at the speed of light, which is roughly 186,000 miles per second, it would take you over 4 years to reach it. That's longer than a presidential term. But let's not stop there. Imagine trying to traverse the breadth of our home galaxy, the Milky Way. Now, this is no ordinary road trip. At light speed, this voyage would require a staggering 100,000 years. That's older than any civilization known to human history. And remember, this is all happening at the speed of light, a pace no current spacecraft can even come close to reaching. The fastest spacecraft ever built by humankind, the Parker Solar Probe, travels at a speedy but relatively modest 153,000 miles per hour. At this rate, a trip to Proxima Centauri would take, brace yourselves, over 6,000 years. These mind-boggling numbers give us a sense of the vastness of the cosmos. They remind us of our place within this grand universe and the enormous strides we still have to make in our understanding and exploration of space. Yet this shouldn't discourage us. On the contrary, it should inspire us. It should fuel our curiosity and our determination to continue pushing the boundaries of space exploration. After all, as the great science fiction author Arthur C. Clarke once said, "The only way of discovering the limits of the possible is to venture a little way past them into the impossible." As you can see, space travel is not a quick trip, but a journey of epic proportions. The vastness of space reminds us of the incredible journey that lies ahead for us as we continue to reach for the stars. Our solar system is home to some incredible sights. Let's start with Mars, the red planet. Its rust-colored surface holds Olympus Mons, the tallest mountain in our solar system, standing 3 times the height of Mount Everest. But Mars isn't only about size, it's also a mystery. Methane gas is detected there, a gas often produced by living organisms on Earth. But where this Martian methane comes from is still a conundrum. Moving on to Jupiter, the largest planet in our solar system. It's best known for the Great Red Spot, a storm that's been raging for centuries, so big it could once fit several Earths. But it's not just the size that's impressive. This storm's longevity is a testament to the immense energy that drives Jupiter's atmosphere. From the known to the unknown, we encounter the Great Attractor. It's not a planet or a star, but a gravitational anomaly. We can't see it, but we can feel its influence. It's pulling the Milky Way and other galaxies towards it, a cosmic enigma that leaves us intrigued and humbled. Let's not forget about the other celestial bodies in our neighborhood. Saturn, with its iconic rings, is an image etched in our collective consciousness. Uranus, tilted on its side, proves that not everything in space follows an expected pattern. And then there's Pluto, smaller than the United States, reminding us that size doesn't always equate to significance. In space, the absence of air and water means metal objects can bond together, a process known as cold welding. It's a phenomenon that wouldn't happen naturally on Earth, a testament to the unique laws at play in the vacuum of space. Our solar system is more than a collection of planets orbiting a star. It's a showcase of cosmic diversity, a testament to the laws of physics, and a constant source of mystery and wonder. From the tallest mountain on Mars to the Great Red Spot of Jupiter, our solar system is full of wonders. Space is full of surprises, isn't it? Just when we think we've got it all figured out, it throws us a curveball. For instance, did you know that metal objects bond together in space? It's a process known as cold welding, and it happens because there's no air or water to form a layer between the surfaces. It's like a cosmic version of a superglue. Or how about the Kuiper Belt? It's a region beyond Neptune, filled to the brim with icy objects. It's like the solar system's personal freezer, stocked with ancient leftovers from its formation. And speaking of size, have you ever considered how small Pluto is? It's actually smaller than the United States. That's right, you could road trip across Pluto. Now let's talk about Uranus, but not for the reason you might think. It's actually tilted on its side, and we're not entirely sure why. Some scientists believe it could be the result of a cataclysmic collision that knocked it off kilter. And while we're on the subject of oddities, let's not forget about Venus. You might want to leave your hat at home if you're planning a trip there. The winds on Venus are incredibly strong, reaching speeds up to 200 miles per hour. That's faster than a Category 5 hurricane. And then there's Mars. You've probably heard about the possibility of life on Mars, but did you know that there's methane gas on the red planet? Scientists aren't sure where it comes from, but it could be a sign of microbial life. But perhaps one of the most fascinating things about space is its sheer diversity. From the icy objects in the Kuiper Belt, to the gassy giants like Jupiter and Neptune, to the rocky worlds of Mars and Earth, every corner of our universe is uniquely different, and every day we're learning something new. These facts remind us that space is not just vast, but also incredibly diverse and fascinating. Did you know how significant our sun is to our solar system? It's not just the bright light in our sky or the source of our warmth. The sun is an astronomical heavyweight, accounting for a whopping 99.86% of the total mass of our solar system. That's right, almost all the mass of our solar system is concentrated in the sun, making it the gravitational anchor for our planets, asteroids, comets, and more. Now let's take a step back, way back, and consider the Milky Way. Our galaxy is a sprawling cosmic city, home to an estimated 100 to 200 billion stars, and spanning a staggering 105,700 light-years in width. To put that into perspective, a light-year is nearly 6 trillion miles, so you can only imagine the vastness of our Milky Way. Our sun and the Milky Way are truly magnificent in their scale. Have you heard about the biggest mysteries of the universe? They're not the black holes or the distant galaxies, but rather two elusive entities that make up a staggering 95% of the universe: dark matter and dark energy. Let's start with dark matter. Despite its name, it's not dark nor is it visible. In fact, it's completely invisible and doesn't interact with light or any other form of electromagnetic radiation. So how do we know it exists? Well, we see its effects on the universe. Dark matter's gravitational pull influences the way galaxies spin, and without it, they would simply tear themselves apart. Now, let's switch gears and talk about dark energy. This is an even more mysterious entity that's believed to be responsible for the accelerated expansion of the universe. Imagine inflating a balloon, but instead of slowing down after you stop blowing, it keeps expanding faster and faster. That's what dark energy is doing to our universe. But what is it exactly? That's the million-dollar question. Some scientists theorize it's a property of space itself, while others think it might be a new, undiscovered subatomic particle. The truth is, we're still not sure. Both dark matter and dark energy are fascinating because they challenge our understanding of the physical universe. They remind us that there's still so much we don't know. Our current understanding of these entities is akin to trying to understand the ocean by studying a single drop of water. But fear not, because scientists across the globe are relentlessly exploring these mysteries. They're using state-of-the-art telescopes and particle detectors, as well as developing complex theoretical models in an attempt to shed light on these enigmatic components of our universe. As we uncover more about the universe, the mysteries of dark matter and dark energy continue to perplex us. But who knows? Maybe one day we'll finally crack these cosmic riddles. Until then, they remain some of the most intriguing and exciting frontiers in the realm of astronomy and physics. Do you know how cold or hot space can get? Well, brace yourself for a thrilling ride through the freezer and oven of the universe. In the shadowy realms of space, far from the warmth of stars, temperatures can plunge to a chilling -270 degrees Celsius. That's just a smidge above absolute zero, the coldest temperature possible. But it's not all a cosmic ice rink. Swing by closer to a star, and you'll find temperatures soaring to millions of degrees. It's this extreme heat that fuels the fusion reactions at the heart of stars, lighting up the cosmos. To survive these wild temperature swings, astronaut suits are ingeniously designed. They're white to reflect sunlight, helping to keep astronauts cool. Layered insulation and temperature-regulating systems further guard against the harsh extremes. Space, it seems, is a place of extremes, from the black holes to the temperatures.